Hey guys, this is Mr. Lowry. Today in class, which would have been day one, we covered this section here, 10.3, arcs and chords. There's three important ideas in here that we're going to use on the homework. And for these theorems here, we actually did some proofs in class. This is the first theorem here. This is on page 536 in section 10.3. And it talks about how minor arcs kind of are related to their chords here. So in this one, what they're saying here is if these two chords, A, B, and D, C, are congruent to each other, then the arcs, the corresponding arcs, A, B, and C, D, have to be this congruent to each other as well. One thing to kind of highlight is this wording right here, if and only if. What that means is the converse of the statement is true as well. So it goes both ways. If the two chords are congruent, then the two minor arcs are congruent. If the two minor arcs are congruent, then the two chords are congruent. And you can kind of go back and forth on that one. Now, like I said, we proved this in class, and part of the proof is here in example 1, right underneath that theorem. Okay, so if you missed class today, it wouldn't be a bad idea to go through that proof and to make sure you understand it, because I may ask questions from these proofs on like a test or quiz or something like that. So you just want to make sure not only are you familiar with the fact, but that you kind of know where it's coming from. Okay. The other idea, or another idea here, is down here at the bottom of 537, the next page. And this has to do with like basically perpendicular bisector kind of idea. So let me get that a little bit closer for you. Sorry, my camera sometimes will unplug itself, and I'm trying to avoid that. So here what we have is a diameter. Let's refocus this. And it's perpendicular to a chord. So if a chord is perpendicular to a diameter, then that diameter cuts that chord in half. So TU and UV would be congruent to each other because of that right angle. Okay. BA, the diameter, also cuts this arc in half. So TA, the minor arc, is congruent to VA, that minor arc. And that's kind of what it says here. So that has to do with, right angles, and if you have a right angle, you basically have a chord bisector and an arc bisector. Okay, so be familiar with that one as well. And then the last one, be really careful with my camera here, is on page 539. Okay. So this says, in a circle or congruent circles, two chords are congruent if and only if they are equidistant from the center. I think that one deserves a little bit of an explanation, so let me see if I can kind of help with that. Okay. There's not really like a picture here to help you, but I think there probably should be. Let's take a regular circle here. Okay. Now you could draw a bunch of different chords in here, but the longest possible chord you can draw is a diameter, right? That's the longest one. As you get farther away from the center, those chords start getting shorter. So it almost looks like kind of like latitude lines on like a globe or something, right? As I get farther to the edge, the chords start getting shorter. So this guy obviously is much shorter than the middle one. Now, the way that distance is measured is always measured at right angles, and that's an important part to this theorem. So let's just kind of talk about, that really quick. Let's say that you were in a room here and you wanted to measure how high it was from the floor to the ceiling, and I took a measuring tape and I measured this way. You'd be like, that's crazy, that's not how you do it. You have to measure this way, like the shortest possible distance. Okay? So another idea here when we're talking about distance is that distance always has to be measured perpendicularly. In other words, we want the shortest possible distance. We don't want like a long diagonal distance. Okay? So let's put those ideas together. The idea of how we measure distance and the idea of getting farther away from the center. Okay? So let's do another circle, and let's do two chords in it. Okay? Let's do this guy, and let's do something like this. Okay? So what we would do is we would like measure a distance here. If we wanted to measure how far away this chord is from this dot, from the center, we would actually draw like a perpendicular like this. We would make a right angle. if I wanted to, again, over here, measure how far away is this chord from the center, I wouldn't draw a line this way. I wouldn't draw a line this way. I'd draw the shortest possible line, which would be a perpendicular line. Okay, so that's kind of the shape you're going to see a lot, you know, in your homework and questions and things like that, is these measurement things. So what this is saying is, as you know, our chords get farther away from the center, they're going to get shorter, right? Well, if those chords are the exact same distance from center, then those chords should be the exact same length. So if I know that this guy is congruent to this guy, then I know that this chord is congruent to this chord, because they're the same distance away. Okay? Now notice the if and only if language again. Okay? If and only if means it works both ways. So going the other way, if these two chords are the exact same length, then they have to be the exact same distance from the center. And again, how you measure that distance is to have some perpendicular lines. Okay? So that's kind of just a rundown of the three ideas that you're going to need to know for this homework assignment. So let's go ahead and jump in. Let's flip the page over and let's see what we got. Okay. Now the directions in the book are slightly different than the directions that I'm going to give you, because I want you guys to justify and write down what you're doing. Okay. So there's 3 theorems. You can call them 10-2, 10-3, 10-4 if you want to. But these problems are really short. Right? They're not too crazy. But what I want you to do is I want you to write down what theorems you're using as you go. I also want you to copy the images over so that you can kind of get used to those facts. I think if you draw, if you write, you're going to remember those facts a lot better than if you just cruise through this assignment as fast as possible, which is not the point. Okay, so let's start with this guy. Okay, let's draw this out here, and then let's start talking about it and what we know, and then we'll start answering some of these questions. Okay, so here's my circle. I'm going to label the center X. Okay, I got a couple chords in there, so I'm going to see if I can. Sorry, it's hard to draw and show you the book at the same time. I'm going to draw some chords in there. Okay, it looks like they're about the same length, but maybe we don't know that for sure yet. We're going to do some perpendicular lines. And then we got all kinds of labels in there. So we got A, B, Y is this top guy. Looks like M is that intersection point, and N is that intersection point. X is the middle. We got D, C, we got Z. And important clue is we have these right angles. Okay, so some ideas that come from this shape. Well, first of all, if these two segments, AB and CD, if those are the same distance from each other, then we know they're the same length. So that's one, and vice versa. If we know they're the same length, we know they're the same distance from each other. That's theorem 10.4. We also have this perpendicular line, right? And theorem 10.3 said if this line is perpendicular, like XZ is perpendicular to CD, then it bisects CD, the segment. It also bisects arc CD. Okay, so those are some things we need to know, and we're going to use those, and we're going to kind of see how we can figure out these missing pieces. Let's put an M in here. Okay, that's this guy, and let's put an N. Okay, so we got a copy here of the figure. I probably should have drawn it a little bigger, but that's okay. We got that guy. Okay, now the first thing we want to find, well, actually, let's go in and use the given information. So here's the circle centered at X. That's what that means, circle centered at X. We have AB, this guy, is equal to 30. So the length of AB is 30. So I'm going to label that guy. We also know that CD is equal to 30. Okay. We know that the measure of arc CZ, this guy right here, is 40 degrees. That's probably what we need to know. So let's look at AM here. Okay, AM. Now we know that AB, the full guy, is 30, and we also know that XY bisects AB because this is like a perpendicular line, and that's theorem 10.3. Okay, so by theorem 10.3, we're going to say XY bisects AB. Okay. We also know AB equals 30, So we're going to do AB divided by 2, because bisects means cut in half. Sorry, I wrote a 5 there. AB divided by 2, that's going to give us 15. Okay? So AM is equal to 15. All right, so that's, that didn't take a super long time, but we, when I look at this as a teacher, I'm like, cool, I know exactly what's going on. I know you understand theorem 10.3, and you can use that fact to find some missing pieces. So that's how you're going to show your work. Okay, let's keep going. 12, MB. Okay, MB has to be the same as AM, right? So we just found that one. That's going to be 15 as well. So AM is congruent to MB, right? That's kind of part of that theorem, 10.3. Bisects means cut in half. Those things have to be equal. So I'm going to say by theorem 10.3 again. So MB is equal to 15 as well. Okay, 13 is asking us for CN. That's that guy. And that's going to be very similar to number 11. So we're going to say by theorem 10.3, XZ bisects CD. Okay, bisects again means cut in half. So we know it's 30 to begin with, right? CD, that full thing was 30. So if I cut it in half, I'm going to get 15. So 30 divided by 2 equals 15. Okay, and I got Cn is equal to 15. All right, 14. We got to find ND, right? Same kind of thing. So there's a little bit repetitive, but the point is to practice so you understand, those theorems, and later on, 6 months from now or whatever, if you're taking ACT, you'll remember that fact. Of course, you won't use theorem 10.3, but you'll remember the fact that if this is perpendicular, if the radius is perpendicular to a chord, it bisects that chord and it bisects the corresponding arc as well. All right, so we needed to find ND. Okay, so again, we know that ND, that segment here, is congruent to NC, if we wanted to call it that. Okay, by theorem 10.3. Also, we're kind of using the definition of bisect, right? That bisect means cut in half. Those things have to be equal. So ND, the measure, equals 15. Notice I didn't put a line above ND because I'm talking about a measurement. Remember, when we're talking about the segment, the shape, we put a line over top. When we're talking about the measurement of that segment, we don't use a line. Okay? All right, let's take a look at some arcs here. So 15 is asking for arc DZ. Okay? DZ. Now, what we know here is that this arc is bisected by XZ, right? Also, theorem 10.3. So we can use that fact and the fact that CZ is equal to 40 that we know these things are the same. So CZ is congruent to DZ. And we're going to go by theorem 10.3. Okay, and so we're going to say that DZ is equal to 40 degrees, the measure of DZ. Okay, let's see what else we got. 16. Okay, we want the measure of CD, that full thing, right? Okay, so again, this is kind of the bisects idea. These two angles together, these two degree measurements together are going to be the full arc. So measure of CZ equals 40, and the measure of DZ equals 40, right? So the full arc would be 40 plus 40 equals 80. So the measure of that was CD, that's what they're calling it. It's equal to 80. Okay, 17, we want AB, the measure of arc AB. Okay, now this may get a little bit tricky here. What we know here is that, or some of what we know, is that these two segments here have to be, we know they're the same length, which means these are equidistant from the center. So that's one thing we know. We need to say something about angle measurements, though. Since the arc measures here have to be the same as each other because the segment measures, the chord measures, are congruent to each other. That means the arcs have to be congruent, and then we have that bisect. So we'll be able to get there. We know what AB is going to be. We just have to, kind of use an idea there. So let's talk about what that looks like. So we're going to do, since we know AB is congruent to CD already, since AB is congruent to CD, by theorem, this is actually 10.2. If the two chords are congruent, then their two corresponding arcs are congruent. So we basically know that CD, arc CD, and arc AB are the same. So theorem 10.2 says CD is congruent to AB, and we're talking about the arcs. Okay, so if the two segments are congruent, their two corresponding arcs are congruent. That's theorem 10.2. And we already know CD. We just found that, I believe. CD, yep, CD was 80 degrees. So that means that AB, the arc, is equal to 80 degrees as well. Okay? 18, measure of YB. Okay, now YB is an arc that we're looking to find, which is half of AB. Okay, now we know it's half because XY bisects arc AB. And again, that's theorem 10.3. So let's write that out. We're going to say, let's see, segment XY bisects arc AB. Right, XY bisects arc AB by theorem 10.2. Yeah, that's the first one in that chapter, 10.2. So we're going to take 80 degrees and divide it by 2, because bisect means cut in half, equals 40 degrees. Okay, so arc, we were trying to find arc YB, right, is half of arc AB. So the measure of arc, measure of arc YB is equal to 40 degrees. Okay. Let's see, we had to go through 22, I believe it was. Okay, so let's keep going. Okay, new figure. I'm going to try to draw this one a little bit bigger so we have something to work with here. All right, so we're using this guy. Okay, I'm going to try to draw that nice and big. I'm always worried when I make big circles that I'm going to not make it to scale, but it looks like we did a pretty okay job. All right, we got to put in a couple radii here. And we got a chord, and we got kind of a middle guy here. We got Q, R, S, P. We know this guy's 3. We got a 90-degree angle. Okay. Also in the instructions here, the radius of the circle centered at P, this guy, is 5. So our radii here, we've already have drawn in, right? About 5. Okay, so 19, we're looking for QR. Okay, that's this length right here. Now, there's actually not, there's not really a theorem we're going to apply here. We're actually going to do, there is a theorem, but it's not a theorem from this section. It's not a new theorem about circles. It's really the Pythagorean theorem, right? So if you think about it, this is a right triangle, and you got a hypotenuse and a leg and another leg. We just need to set this up with Pythagorean theorem. So 3 squared plus this length, I don't know what it is, I'm going to call it QR squared. Now Q and R aren't variables, QR itself is just a number. That's going to equal 5 squared. Okay, so we'll set it up, we'll write what we're doing. Okay, so 9 plus whatever QR squared is equal to 25. Okay, Pythagorean theorem. Subtract 9 from both sides, so QR squared is equal to 16, right? Make sure you can see that. It's QR squared. And then we're just going to take the square root of both sides. Okay, so QR is equal to 4. Okay, now the way I wrote that is maybe a little bit tricky. You might want to just put, like, I don't know, an X here, and you could use X instead of QR. In this case, Q and R aren't variables. Q and R are points. So I don't want to, like, you know, square Q and square R. That's kind of different than what we need to do here. QR is just a length measurement, and so I use that. You could use a different variable if you wanted. But we know now that QR is equal to 4. Okay, and that's 19. All right, let's take a look at 20. 21's QS, right? So what we know is this is, we got this perpendicular guy right here, and if this guy were to keep going all the way out to the circle, it's going to be like a radius. And so what's happening is we got a 90-degree angle, basically a radius that's not quite a full radius, but we can continue it, as bisecting this, this chord. It's also going to bisect the arc. We just don't see that. Okay, so we just know that QR and RS are going to be the same length, which means that if we double that length, then we're going to get the length of QS. So let's kind of put some of those ideas down just so we know what's going on. So by theorem 10.3, we're going to say PR bisects QS. Okay, so if PR bisects QS, that means QR and RS are congruent. So QR is congruent to RS. So RS equals 4. And then, of course, QS is equal to QR plus RS. So QS equals 4 plus 4, which is 8. Got kind of a segment addition postulate idea going on in there, right? We know that the two small segments add to the big segment. So QR plus RS is going to equal QS, and then that's got to be 8. Okay, but again, in order to get that, we have to use this idea about this thing right here being perpendicular to this chord. Now, PR is not a radius, but if you wanted to continue it out, you know, as far as it would be, it would be a radius, and then it's going to bisect that segment. Okay, that's 10.3. All right. Okay, let's take a look at 21 and 22. So different figure. We'll draw that out, and we'll see what we got going on here. Okay. So we got, looks like a diameter coming up straight through, and we got W, T, and Z. So that's what I got so far. I'm just going to keep copying this over. We got a chord called XY, and where that chord intersects the diameter, that point, it looks like it's called V. Okay, so that's what we got so far. It looks like we also got this guy over here, which is a radius. Okay, if you don't see that, that's a radius coming out there. And we have a right angle. Okay, so because we know because we know WZ is perpendicular to YZ, we also know that WZ bisects. Sorry, let me say that one more time. I think I messed it up. Because WZ is perpendicular to XY, that's what I meant to say, we know that WZ bisects the chord XY. We also know it bisects arc XY. Okay, that's one of the things we know. Let's see what else we need here. So in circle centered at T, ZV is equal to 1. Okay, so that's this guy. And then TW from here to here is equal to 13. Okay, and we want to find XV, that's that guy, and we also want to find XY. Okay, it looks like we want 2 segment measurements. Now notice that these don't have like arcs on top. So if you don't see the lines on top, right, these are segment measurements, not arc measurements. when you just have a plain old 2 letters, right? We're talking about a chord or segment or whatever, the measurement. All right, let's talk about what we have here, and then let's, we'll write it out. Now we're looking for xv, which is this guy, okay? It looks like I'm given a radius, right? So TW, notice, is a radius, which means all the other radii are going to be 13. So that means XT is 13 as well, because that's also a radius. So those two guys have got to be the same. That's kind of interesting. We also know that this guy and this guy, ZT is also a radius. Those have to be 13. Okay. Now, if those are 13 together, this little guy VZ with this guy VT have to combine to be 13, and this one's we already know is 1. So it doesn't look like this is to scale, but that means that VT, this section, has to be 12. Okay. So with all that, we can now find XV, which is what we're after, because this right here again is another right triangle. So we're going to use Pythagorean theorem in here. So we're going to say since xt is a radius, xt is congruent to tw, because those guys are all radii. So xt, the measurement, is equal to 13. All right? We also know, let's say also, tv is equal to 13 as well, for the same reason. Because tv is also a radius. Okay? We're going to use kind of a segment addition, segment subtraction here. So since tz is equal to, sorry, I messed up here. Let's go back. We're talking about tz should be 13, not tv. Tz is equal to 13 because tz is a radius. We're talking about this radius right here. Okay. Now, since tz is equal to vt plus vz, right, we know that vt equals 12, right? Again, 13 has to equal vt plus vz, which we already know is 1. So I'm going to put, because 13 plus equals vt plus 1. All right. So basically we got vt now. That's 12. All right. So now we use Pythagorean theorem. Okay. So by Pythagorean theorem, we know 13 squared, the hypotenuse, is equal to 12 squared, this guy. Now, if we want to, we can add a variable. So let's just add like a kind of a random letter here, just so we know what we're doing. We already got z's and x's and y's. So let's use a different letter. Let's just call this guy lowercase b. Okay, like one of the legs. So 13 squared equals 12 squared plus b squared. All right. And then we need to find out what b is, because that's what it's asking for, xv. So this is 169 equals 144 plus b squared. If we subtract 144 from both sides, we're going to get, let's see, is that 25? Okay, good. That works out. 25 equals b squared. And so then we take the square root on both sides, and we get 5 is equal to b. All right, cool. So that's what we were after. Now, remember, we were originally trying to find the measure of xv, right? So xv is equal to 5. Okay, but look at all this like nice justification, right? We got a figure, we labeled it, we're using like, theorems or ideas. We're kind of reasoning through, we're showing our reasoning, and this is, not exactly a proof, but it's kind of using like proof-like deductive logic, deductive reasoning. Okay, and this was all for problem 21. Okay, now we got to do problem number 22. So 22, we're looking for xy. Okay, xy. Now remember that we know that WZ bisects xy by one of the theorems we talked about. It's theorem 10.3. We got that right angle in there. Okay, so let's just use that. So by theorem 10.3, we know WZ, which is a segment, it's a diameter actually, bisects XY, which is also a segment, but it's also a chord, okay? So what that means is the measure of XY, the full segment, is going to be 2 times the measure of XV. Sorry. Full measure of XY is 2 times the measure of X to V. Right. It's going to be double. Okay, now of course we know XV is 5 because we just found that out. So XY is equal to 2 times 5. So XY is equal to 10. All right, there you have it. So we basically did all of those problems, 11 to 22, but you know, we justified them. We didn't just write a number. We didn't just turn in an answer key. And when you turn these in, it didn't take, you know, super long, and I had to explain all of them as I went. But you know, if I were to do that on my own without explaining it, we could probably get there a little bit faster. So not a crazy amount of writing, but you know, just showing me you know what you're doing. I can see what you're thinking. I can see your reasoning process, which is kind of the point in geometry. Okay, so I hope that helps. Remember that any of those proofs that we did in class are subject to be questions on, you know, quizzes or quizzes or tests. So you'll just kind of want to know how to go about proving those guys. 10, 10-2, 10-3, 10-4. And if you're not sure, we can talk about that for after school or something like that. And if I have time, I'll post those proofs for you in Canvas if I can manage that. We'll see how the time goes. But anyway, thanks for watching, and hope to see you back in class soon.